they start adding a whole bunch more conditions. Well, there are some problems that are like this. This is an uglier problem. I shouldn't have started this one, but I'm going to start it anyway. You are going to have in this section and carrying over into the next section on linear programming, 2 additional requirements called constraints. All requirements constrain or limit where the graph can go. X being greater than or equal to 0 means that you always have to be on the right-hand side of the y-axis. X being greater, or excuse me, y being greater than or 0 means you always have to be above the x-axis. So those 2 values constrain or restrict you to only having to worry about the first quadrant. In the practical application problems in the next section, this is almost always going to be true because they talk about manufacturing toys and toy cars and toy slingshots or something like that. You can't make a negative number of cars. You can't make a negative number of toys. You can't have a negative number of people in a room. You can't have a negative age on a car. So negative values in all of the practical applications we use are not acceptable. Not all of them, but we're trying to keep life easy for you, so we're pretty much going to be in the first quadrant. Thing is that they will not always give you the graph that limits the first quadrant, so if these are part of your inequalities, you must include them on your graph. Or the graph, when you shade, will bleed beyond the x and the y axis, and then the program's not going to be happy with you. But it's still going to be intercept graphing. Still going to be intercept graphing. Now, I was a bit short-sighted with this particular problem when I made the grid, or actually when I did the problems, because one of the numbers doesn't really appear on the grid very well. But that's okay. We're going to go ahead and do this anyway. So top equation. I'm interested in these 2 conditions only. What happens if x is 0? Y does all the work. What happens if y is 0? X does all the work, so now it has 11. This particular grid that you have is a 20 by 20 grid. 20 units from left to right and 20 units from top to bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I didn't leave enough room, so I'm going to cheat on this problem. But if you have a workbook page that's like this, you want to pick a scale that's going to allow the graph to fit inside the graph. Problem is that on many of the practical application graphs, you need a big graph because you get lots of weird situations. And now 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 11. So our first line looks like this. Because I've constrained it, the graph on the program will not constrain it, but the shading will constrain it. So it'll go all the way through the axis. You don't have to worry about that. Second one, what happens if x is 0? What happens if y is 0? If x is 0, 13. Y does all the work. If y is 0, x does all the work. So now I need 13. And I need 13. So here's my second line. And now, some of the problems have 2 lines, some of the problems have 3 lines. 3 lines are more challenging, and we're doing that for a reason, to show you that you have to have a better graph of the problem. If x is equal to 0, y does all the work, comes out to be 8. So if you're not having a good day, go to the calculator and make sure you don't make a simple arithmetic mistake. Okay? So if y is equal to 0, then x becomes a value of 20. Let's see, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. So we now have 0 and 8 being connected to 20 and 0. Now this is the problem, right in here. I can't tell whether all three of these lines go through the same point or whether there is actually a situation that looks a little bit like this. I don't know if there is another region sitting in here, if those all go through the same point. This is why when you do your graphs by hand, you want a bigger graph with as large a scale as you can get away with, because how many regions do I have to test out here? Because X and Y have to be greater than 0, I've limited myself to the first quadrant. So look at what I could possibly have. I could possibly have region 1, I could possibly have region 2, region 3, region 4, region 5 sitting in here, region 6 sitting out here, and maybe there is a region 7 that sits inside of there. Adding more lines simply increases the number of possibilities, the number of candidates for feasible region, making more testing for you. So now we're down to testing. Where do you want to start testing?
Region 7.
I can't see 7 very well. It's going to be very difficult to pick a point inside of a region that I can't see. Okay, so I want to make a suggestion to you. I want to see how smart you are, how adaptable you are. If I had the first line, could I have figured out if I should have been on this side of the line or this side of the line very early? So maybe you can do a point test early in the problem. If I had graphed the first line and I had to decide whether I was going to be out here or over here, I could have picked a point and tested early in the problem, right? So let's pick 1, 1. It's clearly on the lower side of the line, right? I'd get as far away from the line as I possibly could. Okay, so I have 1 and 1. 2 times 1 is 2, plus 1 is 3. Is 3 less than 22? So I know that I don't even have to worry about what's out here at all. If I don't have to worry about what's out here at all, look at what that does. It means I don't have to worry about this region, and I don't have to worry about that region. I have knowledge ahead of time. I have to be below the black line. So now it's either going to be this, this, this. I don't have to do 7 test points. I did 1 test point and I knocked out 3 regions, maybe 4 regions in this problem. So maybe we don't wait till the very end to start testing. Maybe we do the test a little bit earlier. Okay? Now, second one. So could it be in region number 2? Well, I could have done the same thing with the blue. Well, as long as we're at it, it's either above the blue line, which means it could only be here, right? We've eliminated these regions that are out here now. So it's either going to be this region, or it's going to have to be below down here. So the same point, 0, 0. Or excuse me, 1, 1. 1 plus 1 is 2 less than 13. So we've just eliminated the possibility of this region, haven't we? So maybe this region? Well, hey, why not? It's either above this, but we've already eliminated these 2 things that are sitting out here and these things over here. So it's either this or this now. I got rid of half of them with the first test instead of waiting until the very end to test. Okay, so now let's try the point 1, 1 again. 1, 1. 2 times 1 is 2, 5 times 1 is 5, 5 plus 2 is 7, and 7 less than 40. Okay, so does it look like It has to be below the red line. So has that eliminated this section up here now too? So where's our feasible region? Region 4. Region 4. Region 4 is going to be our feasible region because maybe if you test early, you can reduce the number of tests that you need if you wait until later in the problem. So here's our feasible region down in here. That we know is the feasible region for ourselves in the problem. Okay, so let's see how we can put that to use over here.